Have you ever looked up at the night sky, stars twinkling against the velvet darkness, and wondered why that darkness exists at all? It seems like an obvious question, but it's stumped astronomers for centuries. In an infinite universe filled with countless stars, every line of sight should eventually land on a star, making our night sky blazing bright. This contradiction is called Olbers Paradox, and its resolution reveals fundamental truths about our universe's age, expansion, and very nature. The darkness between stars each night holds the celestial story of our cosmos, written in shadow and light, unfolding before your eyes. What if I told you that the darkness between stars is actually impossible according to classical physics? That the simple fact you can see black space between points of light in the night sky represents one of astronomy's most profound paradoxes. When you gaze up at the night sky, you're looking at something that shouldn't exist. If the universe is infinite, has existed forever, and is filled with stars, then every single line of sight should eventually intersect with the surface of a star somewhere in the vast cosmos. Think of it like standing in a dense forest. No matter which direction you look, your vision inevitably stops at a tree trunk. You can't see beyond the forest because trees block your view completely. In an infinite universe packed with stars, the night sky should appear as a dome of blinding brightness, as luminous as the surface of the sun itself, with no gaps or darkness. This logical contradiction between what we observe, a dark sky with isolated stars, and what theory predicted a blindingly bright dome, is known as Olbers Paradox, and it troubled astronomers for centuries. The paradox has a rich history dating back to the early 1600s. Johannes Kepler first documented this problem in 1610. Already renowned for discovering the laws of planetary motion, Kepler couldn't reconcile the darkness he observed with his understanding of the cosmos. He suggested the universe might extend only to a finite boundary, beyond which lies empty space, potentially explaining the darkness. As curiosity deepened among early astronomers, new theories emerged. Heinrich Olbers formalized this paradox in 1823, articulating the problem mathematically. If the universe is infinite and filled with stars, the night sky should be uniformly bright. Despite not being its original discoverer, the paradox bears his name today. Olbers proposed that interstellar dust might absorb light from distant stars, creating the dark patches we observe. Initially, this explanation seemed logical. However, it quickly falls apart under scrutiny. Any dust capable of absorbing that much starlight would eventually heat up to stellar temperatures. The dust would begin to glow, re-radiating the absorbed energy, ultimately resulting in a sky that remains uniformly bright. Other astronomers suggested that stars might be arranged in specific patterns with large voids. But in an infinite universe, these arrangements would average out over cosmic distances, still resulting in a uniformly bright sky. Each failed explanation forced astronomers to question fundamental assumptions. What if the universe isn't infinite? What if it hasn't existed eternally? What if stars don't shine forever? These questions pushed scientists to reconsider basic principles of cosmology. The resolution to Olbers' paradox came from recognizing that our intuition about an infinite and eternal universe was incorrect. The universe has a finite age. Light from the most distant stars simply hasn't had enough time to reach us. Furthermore, the universe is expanding, stretching the wavelengths of light from distant objects beyond what our eyes can detect. These revelations emerged from decades of astronomical observations and theoretical physics that transformed our understanding of the cosmos. The darkness of night, something so common we rarely question it, turned out to be evidence of cosmic evolution, a window into the universe's structure and history. Imagine if the universe were truly eternal and infinite as early astronomers believed. your night sky would blaze with the light of countless stars in every direction. The darkness you see when gazing upward isn't a void, it's one of the most profound clues we have about our universe's beginning and ongoing expansion. Modern cosmology has finally answered the question that puzzled astronomers for centuries, and the solution comes from three key insights that completely transform our understanding of cosmic darkness. But before we jump to 21st century astrophysics, let's take a fascinating detour through literary history. In 1848, while scientists were still struggling with this astronomical riddle, Edgar Allan Poe, yes, the horror writer, proposed something remarkable in his prose poem Eureka. Poe suggested that perhaps we can't see infinite stars because the universe hasn't existed forever. Light from the most distant stars simply hasn't had time to reach us yet. This brilliant literary insight came decades before scientific evidence confirmed his intuition, making Poe an unlikely pioneer in cosmological thinking. Poe's insight touches on what astronomers now call our cosmic horizon. The universe began approximately 13.8 billion years ago, which means we can only observe objects whose light has had sufficient time to travel to Earth. Picture standing in a dense fog where visibility extends only a few feet around you. Objects beyond that distance exist but remain hidden, not because they aren't there but because their light gets lost in the journey. Our cosmic fog operates similarly, except it's created by the finite time light has had to travel since the universe began. This finite age creates the first explanation for our dark sky. The cosmos has a beginning, limiting the number of visible stars to those within our time-bound bubble of observability. The universe is also constantly expanding. Imagine a balloon with dots drawn on its surface. As you inflate it, the dots move farther apart, not because they're moving across the balloon, but because the surface itself stretches. Similarly, cosmic expansion stretches space-time, carrying distant galaxies away from us and stretching their light waves in the process. This stretching effect, called redshift, transforms the visible light from distant objects into longer wavelengths our eyes cannot detect. The light energy reaches Earth but has shifted from visible light to infrared, microwave, and radio waves, rendering many cosmic objects invisible to the naked eye. The third factor involves the stars themselves. Stars form from gas clouds, burn for billions of years, and eventually exhaust their fuel. Unlike the eternal beacons in early models, real stars have lifespans. This means not all potential stars are shining simultaneously. Many haven't formed yet, while others have already burned out. Together, these three factors, cosmic age limiting observable distance, universal expansion stretching light beyond visibility, and the finite lifespans of stars, combine to solve the puzzle of our dark night sky. Interestingly, the night sky isn't completely dark. The cosmic microwave background radiation, the oldest light in the universe, fills the entire sky but remains invisible to human eyes because expansion has redshifted it to microwave wavelengths. This omnipresent glow represents energy released shortly after the Big Bang, a faint echo of creation itself permeating all of space. But the most remarkable thing about Olbers Paradox might be that you can verify the evidence yourself. With simple radio equipment, you can detect the cosmic microwave background radiation, that ancient echo of the Big Bang. And if you have access to an amateur telescope, you can observe the redshift of distant galaxies firsthand. These aren't just abstract concepts, they're observable phenomena that transform our night sky into a living laboratory. The next time you look upward during a quiet moment, allow yourself to feel both wonder and profound peace. The darkness itself is a window through which we glimpse the universe's biography, written in a language older than words. a reflection that connects us to the deepest rhythms of existence.